Okay. All right, that should be good. All right, so last time we talked a little bit more about basic class things that we do in class. So in a Java class, we've got our fields, which are just the variables. We've got our methods, which are the things that do something. And we've got our constructors, so the things that create the object. So we looked last time at a seminar and professor class. And I think I've closed that VS Code window. Okay, so we had a professor class where we've got our fields and we've got our constructor. So for professor, we just had one. And then we've got our getters and setters. So these are methods that belong to the class professor that we can use to access or modify the private fields that belong to professor. And similarly for seminar, we've got private fields. We've got several different types of constructors. These different kinds of constructors help us to initialize this seminar object depending on what sort of data we have available. So if we have the type and the professor object available, we're going to initialize it with that information. If we don't have any of that, or we don't want to give any of that, we have a 0 parameter constructor to give it this information. We also have a copy constructor. So if we want to create a copy of this seminar object with the exact same information, we can just give it an existing seminar object and just use the getters to get the type, get the reading, get the professor, and assign it to this object so that this object has the same information as the object given to us in the parameter. So we've talked about setters and getters. And so now we're going to do another example. So we're having a lot of examples for this because it's an important topic for you to wrap your head around. So we've got the professor and seminar one, we've got the book and author one in the lab, and now we're going to have a combo lock where we're going to create a Java class to model a combination lock. So if you remember, there's a combination lock. Let's like something like this, you know, that image is tiny. Where, you know, you spin it once and you do one number and then you spin it another time to another number and then you spin it a third time. And then finally you can pull and open it. And so that's the goal for this. We want to model this sort of behavior. So a combination lock is going to have 3 numbers. And that information we want to be secret. So we don't want the user to know, hey, here's the numbers to my combination lock, because that would defeat the point of having this lock, right? We don't want everyone to know what the combination is. We only want the select few people to know what the combination is. So the combination is going to be hidden. The lock, and so that's the first thing, the combination. We want to be able to open and close the lock. So those are going to be 2 methods. We're going to have a method to open it by providing the combination. We have a method to close it. We're also going to have a method to change the combination. And the thing for that is we can only change it if we know the existing one. So that's a typical thing, you know, like if you're going to go change your password, it asks, give me your old password first to make sure that it's really you. So if we want to change the combination, we need the old one and the new one. Okay, so that's what we're going to do. We're going to make a class that does this. So let's go over to VS Code. I'm going to, man, I got to organize this. We'll do it when we get to packages. Okay, so Command-Shift-P new Java file, class, and my class name is ComboLock. All right. How should I store the combination? What do you think? Ideas? There's multi, go for it. Private, yeah. So how does, I feel like we're missing something. So a combination lock, yeah. So a combination lock has 3 numbers. So there's different ways to go about this, right? Maybe we have a string for each one of them. Maybe, and so like if the string matches, then the one that I have in my solution, I have like N1, N2, N3. And so there, but we could also have like private int. We could have like save it in an array. And so like each number is the like number 0 is the first number, number 2, and number 3. So like we could do that too. I'll leave it as 3 separate ints, but just know that there's options. So we want to model a combination lock. The way that you do that is really up to you. But for now, we're just going to save each number as an integer. And they're private, so they're not public. Oh yeah, thank you. Okay, so let's actually do the generate constructors. And so let's ask this question. So what kind of constructors do we want? Would it make sense to only have a constructor with like 1 or 1 and 2 or 1 and 3 or something? Do we think that makes sense? No, because for a combination lock, having all 3 numbers is really important. So we want our constructor to use all of them. So okay, so that's another constructor. There's another way we can do that. So, or not another way we can do that. I want another constructor for a 0 parameter constructor, partially because I want to show you something. So let's say if we just create a so-called empty combo lock that maybe it initializes to 0, 0, 0, right? I feel like that's fair. To do that, we could say this dot n1 equals 0, this dot n2 equals 0, but I don't know, that's a lot of typing. Another way to handle that is to just call this. So if you remember, this is a keyword that refers to the current object the current object of this type. So the current combo lock. And so we can call, because we know the combo lock constructor defined for 3 integers, we can call that constructor. So the line 17 is calling the combo lock constructor and just giving it 3 zeros. Okay, so let's have a method to open the lock. So okay, the first question, how do we get the combination? What sort of things could we do to get the combination? Say that again? Setter and getters. I'm thinking more like from the user. So the idea is, yeah, so we could use a scanner. I don't really want to do that right now. Scanners are a bit of a pain. We could get it from like command line arguments. We could also do that. So I'll put a note in here. That's also a possibility. And maybe if we were writing a more robust version of this, I think that would be a fair assumption and something that you could definitely do. So what's the other option to get this input? Parameters. So remember, when we're defining this method, the things in here are parameters. When we're actually working with like a combo lock C, and we call C dot open something, the things that we actually give it, those are arguments. So the parameters are what we define like in general, and the actual things that we give it when we use it, those are arguments. So what should our parameters be?
Lock.
A lock?
Yeah.
Yeah. So we're not taking, the idea is to call C.open something. So we want to take the three parameters for the open method are going to be the user's guess. So these are not guaranteed to be correct. They could be completely wrong. Okay, so what do we have to do? Under what condition are we going to say the lock is open? Comparison of what?
The number they give you and the actual numbers.
Yeah. So we're going to say something like, so we'll probably have an if statement, and we'll say if this dot n1 is equal to n1, and this dot n2 is equal to n2, and this dot n3 is equal to n3, then we can print the lock is open. Hooray. What would happen if we change these for or? Does it change the meaning of checking the combination? Yes. Why? Yeah, Lachlan. Yeah. So if all of these were or if n1 matched, then we're like, okay, the first number matched, the lock's open, which we don't want. So we want each number to be correct and in that order. So we really do want these to be ands. Okay. So that's for open. What about close? First of all, do we need any parameters to close a lock? We're thinking about just like your average locker combination lock. Do you need anything to close it? Not really, right? You could scramble the wheel and still be able to close it for most locks. So I think no parameters. How do we want to keep track whether the lock is open or closed or not? Any ideas? Have something be printed. So like go by whatever was printed previously. That works. I think maybe like we would probably want to add some functionality to this class. So yeah. 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 So what I have in my notes is I have it as a Boolean of like true, or I have the Boolean, it's called is open. And so if the Boolean is true, then it's open. If it's false, then it's closed. A string is also a good way to go about it. I feel like maybe having a Boolean makes the logic easier. But having a string is also a perfectly valid way to go about it. But wait, let me see. I call it is open. So I have a Boolean called is open, and that way when the Boolean is true, then the lock is open. When is open is false, then that means the lock is closed. And so when we initialize our lock, do we want it to be open or closed? I think either could work. What do you think? Closed? Yeah, sure. Let's go with that. Okay. So now instead of lock is, or we can still print lock is open. What do we need to put here? Yeah, Monty.
This is open to me.
Yeah. So all the numbers matched. And so now our representation of whether the lock is open is true. So the lock's open. There's probably something else that we need now that we have this mechanic. There's something else that we need for this method. What do we need? Imagine we have a combination lock. We've just opened it. What if we try to open it again? Do we want that to happen? Does it make sense? Probably not, right? Like if we've got an open lock and we put in the numbers again, nothing's really going to happen because the lock's already open. So we need some logic in here to check, is it open? So we can say if this dot is open, then I don't know, maybe we print lock is already open. And then we can return. So that way, we don't check the combination lock if the lock's already open. This is handy for Booleans. It's a handy shorthand. It's equivalent to saying something like if this dot is open equals true. Since we know that the variable is a Boolean, we just give it to the if statement. And so when it's true, it's going to enter the if statement and print this. When it's false, it will not enter the if statement because the lock is closed, so it's not going to print. The lock's already open. Okay. What happens if we gave the wrong combination? Maybe we want to print something. Maybe we want to say that the combination okay, it's about to be a lot of numbers. Let me do print F instead. Okay, remind me, integer is D, %D, I think. Is incorrect. Okay. I may not be remembering this correct off the top of my head, but let's try. Format type. Oh, okay. I've forgotten how to do printf. Yeah.
If I wrote formatted, then
With the format,
then just add another PED. Or is that a different method?
then, did you do print ln?
No, I didn't.
Okay, printf and then the string, then dot format.
Formatted.
Ah, okay. Cool. Okay, so what we did here is instead of print ln, we have printf, which allows us to, instead of writing plus n1 plus n2 plus n3, we can just stick the variables in here at the end, and because I think %d is integer. Wait, is that wrong? Okay, let's see. Let me show you how to do that. So, Java printf. Let's Google it. I trust W3 schools. I also mostly trust Stack Overflow. And so it says D decimal integer. So yeah, I think it is D. And so the thing that goes after the % depends on what sort of variable you're inserting. So if it was a string variable, then it would be %s. If it was like a decimal number, like with a 4.2, then it would be %f, and so on. There's other options. Was there a question? I saw a hand. Nope. Okay. Okay, so this allows us to print, hey, you tried this combination, but it didn't work. So we did printf and then had %d because I have 3 integers. And then after that string is done, I have dot formatted. And then I give the order that I give these is the order that they're going to appear here. So if I had given it 3, 2, 1, 3 would show up here, 2 would show up in the middle, 1 would show up at the end, which is not the order that I want. I want it to be the order they gave me in. Okay. So for close, what do we need? What do we need to close the lock? Go for it.
So is it full stop?
Okay, so we can say if this dot is open equals false. We could also just do that shorthand by negating it. So if we have the exclamation point in front of this Boolean variable, this says literally, if not this open. So if this open is not true, then do whatever's in the if statement. And so this says if the lock is closed, then is open is going to be false, right? If the lock is closed, is open is false. If the lock is open is true. So in this case, this is the case where we're trying to close it, but it's already closed. So we'll print lock is already closed. And then return. I have a return statement here, even though it's a void method. In Java and in most coding languages, I think, even if your method doesn't return anything, you can force it to stop. So in this case, I'm going to have code after this if statement, but I don't want, if the lock is closed, I don't want any of the code below here to be executed. So I can just say return right here, and then we're done with this method if the lock is already closed. So I'm not returning anything. I just have return semicolon, and that ends it. Okay. And so for closing, we don't have to check anything. So we can just say this dot is open equals false. And then we can print lock is now closed. Okay. All right. The other thing, we probably want, the user probably wants to know whether or not the lock is closed. So I might generate a getter for which. So, okay, does it make sense to have a getter for N1 through 3? Does that sound like a smart idea? No, it's not, because we don't want the user in any way to be able to get the secret numbers to our combination lock. That's bad. But I think maybe the user would probably want to, like, you can look at a combination lock and see if it's open or closed by whether you can see like the shackle. So in with Boolean fields, when you have getters and setters, or I think just getters actually, it's just going to give you the name of the Boolean. Because we've named it, the Boolean is open. And so the getter name is just the name of the field because it tells you that, like, whatever this method returns, it's going to be true or false. And so just in terms of naming conventions, it's not named get is open, it's just is open because it's a Boolean. And so it makes it a little bit special. Okay, so we've got we've got open, we've got close, we've got is open. We need to also be able to change the combination. So I'll have a method called change combo. And this is where we're going to have a lot of parameters. So for changing the combination, we need the 3 original numbers and we need the 3 new numbers. So int n1, int n2, and int n3. Those are going to be the original ones. And then we need, let me call it new 1, new 2, and new 3. So a lot of parameters, but we need all of them. Okay. And so to actually change the combo, we need to check the original combination, right? We have to check that these guys are the same as our current combination, and then only then these new numbers are the new combination. So we could just copy and paste this into our new method. I'm not going to do that. And so for this very small example, it doesn't really matter. I could copy and paste it and that would be fine. But let's say I was in a situation where I'm working with code and this calculation is really, really, really long. Or maybe it's more intense than just checking if three numbers are equal to each other. In this case, we're going to kind of outsource this calculation to another method because we're doing this calculation twice in the class. We're doing it in open and we're also doing it in change combo. So instead of copying and pasting the same exact code, I'm going to put this checking into a separate method. That way, if later on I add a method that needs to check the combination, then I can just call that method. And if I need to change the way that I check the combination later, then I can just edit that method. And then I don't need to go into every place that I have had that code and change that. So we're going to shift things around a little bit. And this might be the last thing. So instead of, okay, I'm going to cut this. Are you familiar with cut? Like cut and paste? So for me, it's Command X, and that copies it to my clipboard and removes it from here. It's the same as like copy and then delete. But so I've cut that, and then I'm going to have a method, not change combo, check combo. And I'm going to return, so let's say I'm given these three numbers, and I'm going to return whether or not those three numbers match my combination. And so this is the exact same code that I had in that if statement. So I'm just returning the result of these logical operators. So it's going to be either true or false. So if I return that, I've currently got an error here in my if statement. And so instead, I'm going to say, I'm going to call check combo, and I'm giving it N1, N2, and N3. Those are these guys. And with that, I have successfully checked the combination. This is returning a Boolean, so it's good to be in my if statement. And then down in change combo, I can say if check combo N1, N2, N3, then I can change the combination. So then I can say this dot N1 is equal to new 1, this dot N2 is equal to new 2, this dot N3 is equal to new 3. And maybe I close the lock after I've changed the combination. And then maybe we want to print something to the user. So we can say The combination is changed. The lock is closed. So the other thing I probably need is, so if the check combo is good, then we can change it. Otherwise, maybe we want to print. Like your original combination is incorrect and please try again. Okay, so that means we're at 310. So for active learning today, just submit what you've got with ComboLock. In terms of homework 1, you can absolutely start working on it. Find a partner and start working on it. However, I've pushed it. So homework 1 is currently now due on the Tuesday of the week of fall break. I wanted to give you a chance this week to catch up on stuff. So this schedule is probably going to shift around a little bit. So spend your time. If you're not at 100% with lab 1, 2, or 3, spend time this week and work on it. I have office hours tomorrow. I'll be in there 3 to 5. Again, if you come 3 to 4, my 102 students have priority. 4 to 5, you have priority. So come ask questions. If you can't come to office hours, send me an email and we can work out a time to meet outside of that. I want you to succeed. I want you to get 100%. So come talk to me. All right, thanks. And I'll see you on Thursday.